All right. Hello, InVEST NatCap community. My name is Doug Denu. I'm the software team lead at the Natural Capital Project, and I'm excited to be here to talk about a new feature coming to the InVEST Workbench, and that is plugins. But luckily, I'm not alone to talk about it by myself. I'm here with Emily Soth, who is also a software engineer at the Natural Capital Project and the technical lead on the new feature. Hello, Emily.
Thanks, Doug. Happy to be here.
I'm also joined by Peter Hawthorne, a longtime NatCapper and co-founder of Natural Capital Insights. Hello, Peter.
Hi, Doug. Hi, Emily. I'm glad to be here too.
Awesome. If you're new here to InVEST, generally, InVEST stands for the Integrated Valuation of Ecosystem Services and Trade-offs. And InVEST is our suite of free open source software models used to map and value the goods and services from nature that sustain human life. And so we have both a Python package for InVEST software as well as a desktop application with a user interface. But kind of recently, we've run into the question of, boy, wouldn't it be nice if I could have a slightly different version of a core InVEST model that I could run in the Workbench? Or what if I want to have a completely different ecosystem service model that is not captured by what InVEST currently kind of supplies in our core package? And so that's a little bit of where the idea of having a plugin feature for the InVEST Workbench came from.
So conceptually, an InVEST plugin is an ecosystem services model, but unlike our core InVEST models, anyone can develop a plugin and run it in the Workbench and share it with others and let them run it in the Workbench without having to go through the NatCap software team. And this is great because we've heard from people who want to run custom versions of our models or want to develop their own models from scratch that they'd like to be able to use in the Workbench. And now that is much easier for them to accomplish. It sort of evolved naturally from some previous work we had done around improving the structure of our models, making them more consistent throughout InVEST, and developing more structured metadata. And then when a cross-Stanford collaboration came along that required an InVEST-like model, but would have to be customized from the ground up, I think that's what pushed us to formally develop this plugins idea.
The nice thing about plugins is that it kind of removes the burden for those things where we get the user interface from the Workbench and the distribution of the Workbench kind of for free. And so it takes a lot of that burden away and allows, us or modelers to be much more focused on that unique application that they're going for.
So you're just talking about distribution. What's the plan for how the plugins will be distributed? If they're not going through the software team, will there be a central repository for them, or will it be community driven, or what's the idea at this point?
Great question. So a plugin is just a Python package, right? So it can be distributed in the same way that you would distribute any other Python package through like PyPI, GitHub, these things that people are already hopefully familiar with using. So starting out, we are not offering any kind of centralized distribution system for plugins. It'll be up to the plugin developers to decide how they want to go about that. But it's definitely something that's on our radar, and in the future we might offer some kind of way to help the community discover other plugins that are out there.
It'd be great to kind of quickly talk about a little bit of the any kind of like fun challenges that we had to overcome. Emily and kind of design ethos of what we wanted to make sure we got right before releasing this kind of feature.
Yeah, so this feature has been in progress for over a year now. Because we've been building this totally from scratch, there have been a lot of design decisions to make around like, what does a plugin look like as a standalone project and how is it distributed and installed? And what we really wanted to get right here was having something flexible that's going to be useful for a lot of different use cases and something that we'll be able to iterate on as we get more feedback. So I think the basic design that we've landed on of plugins as Python packages is really going to help us achieve that.
Cool. Let's dive into a screen share and see what plugins are all about.
Thanks, Doug. So here we are in the InVEST Workbench. We are pre-recording this before this feature has actually been released, so you are getting a sneak preview, and don't be surprised if things look slightly different by the time that you're seeing this recording. But we have a new button up here, Manage Plugins, which takes us to this screen. And so, say I wanted to install a new plugin. So we're using GitHub here, which we expect most users will be familiar with as a means to share and make public their software project. I'm going to go here and click on the code button and copy the Git URL, just as if I was going to clone this repo. And I'm going to plug that URL into this box and click Add. And this may take a few minutes, but what's happening behind the scenes here is the Workbench is downloading that plugin, creating an environment for the plugin to run in with all of its dependencies and everything that it needs, installing the plugin, and then it should pop up in our list of models.
So this is going to install a local copy of that repository, right? Of that code.
Exactly.
Well, I'm curious about updates then. If the developer decides to fix a bug or develop a new version or a new feature, how would I know about that, or how would I get the update?
Yeah, good question. So one of our design goals for this feature was for users to be able to have multiple different versions of a model or versions of a plugin coexist and be able to run in parallel in the Workbench at the same time to facilitate comparing those and seeing differences between them. And so because each plugin is installed into an isolated environment, they won't conflict with each other, and that's possible. So it looks like our plugin has finished installing, and we can see now it's appeared here in our list of models with a tag indicating that it is a plugin, differentiating it from our core models. When we open it up, we expect it'll take a little bit of time to start on the first run as it's initializing that environment.
One nice thing to know, Emily, maybe is that the environment that the plugin is running in is independent of what the InVEST Workbench is running in for an environment. Is that right?
Exactly, yeah. For folks who are familiar with Conda, this is using Conda under the hood to completely isolate all of the dependencies that this package is using.
That's great to hear, because there's nothing more painful than having package inconsistency in your Conda environment and needing to fix that. I'm thinking a little bit about sort of what interface options there are for plugin developers. So what sort of form features would I have? Can I use radio, dialogues, select boxes? In the models that we're thinking about, there are lots of choices the user might make to specify one set of options versus another. I know a lot of InVEST models come with different choices. Are those all available to the plugin developer?
Yeah, so all of the user interface options and types of form fields that we already use in InVEST will be available to plugin developers. The way that is controlled is it's automatically generated from some structured metadata that you would provide in your plugin module. So we're able to say, for instance, if this input is an integer, then we know to automatically render this type of input box. And so things like drop-down menus, checkboxes, other things that you've seen in our other models will also be available.
Cool.
Yeah, and I think that's something over time, as the community kind of gets a hold of this and uses it, plays with it. If there's certainly things that stand out that are missing, that would be extremely useful for community developers. Really excited to work with you and all of them to continue to work on this and add features where it makes sense. We definitely have a philosophy of pragmatic and practical, and so if there's a good case for adding some functionality, we are definitely interested to hear that feedback.
So this test plugin is very simple. All it does is take in a raster and multiply every pixel in that raster by an integer factor. So let's go with 2.
Very risky.
So that was very fast. The model completed, and we should be able to open that workspace and see the results.
We touched on it a little bit, but kind of just to summarize what I think one of the real benefits of this feature provides is you get a lot of things built in for free by having a plugin go through the workbench. You have the already established user interface that the workbench provides, which kind of handles those input fields, also gets you data validation to provide those kind of feedback if there's a field that is missing or is not kind of correct. You also have logging that is built in as well as part of the workbench, as well as being able to load and save your data parameters.
For example, if I forgot that this was supposed to be an integer and I instead put in 2.5, I immediately get some feedback telling me what's wrong so that I can fix it.
What else do I need to do as a developer to take my model and make it ready for the workbench? Talk about the metadata documentation, but are there other things I need to do to the code?
Great question. So the main thing will be just structuring your model as a Python package. This is our demo repo, which we will have fleshed out by the time that this feature is released. But basically, you'll have your source of your model as a Python file. We're hoping that this will be accessible to a lot of people since Python is a popular language and many of our users are already familiar with the Python API for InVEST. So here's an example of what that structured metadata might look like. We have specified in here information about all of the data inputs and outputs that your model produces. And based on this information, the workbench can generate that UI and data validation for you. Then, like any InVEST model, we're looking for an execute function, which runs the model itself, and a validate function, which performs the data validation. And so once you have a Python module that meets those basic API requirements, it's pretty much just plug it into the workbench.
Nice. That's a pretty low barrier to entry.
We hope so.
One of the things that we've been working on that we're excited to share is a model for in-stream water quality. So the InVEST has a very landscape-focused set of tools. I'm thinking about the nutrient delivery ratio model in particular, which tracks how nitrogen, phosphorus move across the landscape and are captured, but then some ends up in the stream. And the question that we've been asking is, well, what happens to it then? We know that, for example, in a lot of agricultural landscapes, wetlands do an enormous amount of work to improve water quality as that nutrient actually moves through the stream network. So when we're thinking about what's the best way to manage water quality within an agricultural context, some of it is about changing the landscape, but some of it is also about changing the sort of the wet landscape, or what's happening within the river network. So the question was, how can we link what's happening on InVEST, which is super valuable for that landscape context, with this other portion? So there was a model that some colleagues developed, originally written in MATLAB. It was called the nitrate network model, and we've ported it. It's in its third language now. It went through brief incarnation in Julia, and then we brought it over to Python, thinking forward to this integration. And that model is basically built to take inputs, or the outputs from NDR and seasonal water yield, and then a number of other things that you need to put together, like defining where your wetlands are and how the various portions of the stream network are connected with each other. But then it can start to process, tell you what's happening to the nitrates and other forms of nitrogen in the streams. And so we think that plugins are a fantastic way for us to share that model, get feedback, start to expand its scope of application. We've used it, and it was developed in Minnesota, and we're piloting it in a few other locations in the US, but it should be able to move out to more and more locations around the world, since the processes are fairly generic.
That sounds like a really natural use case for plugins, extending and taking advantage of some of the core InVEST models, and then adding a whole bunch of custom functionality. I guess maybe first I'd be curious of what you kind of think of as like the biggest benefits of plugins that it provides to what you're trying to do there.
I think the biggest benefit is accessibility. I think that one of the major strengths of InVEST is that it lets a lot of people in the door to running ecosystem service modeling without needing necessarily to go write your own Python scripts. And so we basically want to be able to provide that with this new model. And previously it's existed in a download link linked from a paper that you'd need to find somewhere, and being able to share it through this platform will be incredibly helpful in broadening its scope and its reach.
I'd just like to point out that for anyone out there who has a model that's already developed in a language other than Python, you don't necessarily have to rewrite the whole thing into Python for this to work. So the plugin can function as a wrapper as well, as long as you're able to invoke that external code from a Python module and provide the necessary structured metadata. What that model actually does can be totally up to you.
We hope to allow folks to share their research, their models, as easily as possible, to iterate, prototype, and get into other people's hands. And so, very excited for seeing that, and seeing that certainly in your use case. And if there's enough Julia fans out there that want native support, make an issue, and we'll see how many thumbs up it gets, and maybe it's something we could put on the feature roadmap.
Wow, I know what's going on my to-do list.
Excellent. All right, thanks everyone for taking the time to listen in, and we'll check in with you later.